Hello everyone and welcome back to our course. In the previous lecture, we tested in Unreal that our game mode was able to spawn enemies during the game's run. And we did that by implementing the tick function inside of our game mode, and then setting up blueprints for our enemy and our game mode. In this lecture, we're going to have those enemies chase us. So let's go into the enemy controller C++ file. All right, here we are going to write some code inside of the tick function for the enemy. That means that we'll be able to move the enemy every frame of the game. And each enemy is its own entity, so each enemy will behave independently. The enemies won't all be moving together, they'll be moving separately. Because each time an enemy is created, a new instance of this enemy controller class is created. So let's get started. First, we need to get the location of our enemy, then we can adjust it. All right, so let's first grab our enemy's location. A location is stored as an F vector. We've seen that before. And let's call this our enemy location variable. I'm going to use the function getActorLocation to get the current position of my enemy on this tick. And we'll do that at each tick. Then we can just change this by a certain amount. For example, in a direction and by a speed, and with delta time included to make sure that the speed of the enemies is the same regardless of the frame rate of their device. Alright, so let's go ahead and adjust this enemy location. We can take enemy location on one of the axes like X, and we can add to it. Now we're choosing X because that is going to be moving left and right. Y is forward and back, and then we have Z, which is up and down. So let's use a direction dot X. Then we'll have to define direction. So this is going to be a variable that is part of the enemy controller class. Let's define it inside of the enemy controller header file. Notice that I'm using its .x property because I'm going to store the direction as an F vector. All right, so let's go into enemy controller.h, and under our public properties here, let's create another one. This is going to be an F vector, and I'm going to call it direction. All right, there we go. By default, it's just going to have the values 0, 0, 0 for an F vector. Then back in our C++ file, we can now put to use direction. Sometimes it can take a bit for it to catch up with the changes that you made in the header file. So you could speed that up by building the solution, because sometimes when you make a change in one file, it can take a while for it to catch up on the other file. Now, how do I set what the direction should actually be? Because currently we just have direction as being 0, 0, 0. Well, let's go into the code where we spawn each enemy. Okay, so that's going to be inside of our game mode, our C++ file, and here we have, there we go, spawn actor, which spawns an enemy. Here we can also set the direction of the enemy. We want the direction of the enemy to be toward the player. So what we need to do is get an arrow or a vector that can point to the player from the enemy. Alright, so we have to get the difference between where the enemy is and where the player is and make an arrow to point from one to the other. So for that, I'm going to grab my enemy and I'm going to set its direction property. And what I'm going to do is first subtract my player location minus my enemy location, so to get the difference. Then if I want to turn that into an arrow instead of just an F vector, I'm going to use the function getSafeNormal. GetSafeNormal is a useful function. It returns an arrow that has size 1, and it's all about direction. So it just has a size 1, but it's going to point, and that way we can actually point from our enemy to the player. All right, let's go back into our enemy controller C++ file. And now our direction is not just 0, 0, 0 as we instantiated it, but actually whenever an enemy is spawned, as soon as it's spawned, we're going to change its direction to point at the player. Okay, so now we know this direction is coming into use, and not only that, but we're actually now going to change the enemy's location. So that means we're actually moving them along that arrow of the direction. We're moving them toward the player. But this is just on the x-axis. We also have to move them on the y-axis. Otherwise, they would never actually reach the player exactly. They'd only reach them on one axis. So let's grab the enemy location.y and add direction.y. You may be wondering, what about direction.z? Well, direction.z is up and down. So if we had flying or jumping that we wanted to allow the enemies to do, then we could also change their direction on z for sure. We can leave it at this for now. Okay, and we also have to now set our actor's location, because sure, we set this f vectors x and the f vectors y, but this f vector is just a variable. It's just storing some data. It's not actually affecting the enemy actor. If you want to actually affect the actor in the game, you have to specify that with a function. So I'm going to call setActorLocation. This is similar to getActorLocation, but instead of just getting or returning a value, we're actually mutating or changing a value. So this is the line that's actually going to move the enemy. And how are we going to move it? We're going to move it to the enemy location, its new location. Originally, its location was just wherever it was on that tick, but then we moved it along this arrow toward the player. Now we also want to adjust it by a speed typically, because if you just set it like this, it'll move really slowly because direction.x direction.y. The maximum value they can have is 1, because remember that get safe normal is an arrow of size 1. So let's apply some speed and delta time to this location change that we're doing. I'm going to go back into my enemy controller header file. Here, I'm going to create a float, and I'll call this speed, and we can set this to something like 100.0 f. Okay, so here, that means we're going to move them 100 times faster than before. This may seem like a lot, but we can play around with this value. You could also make it editable in the Unreal Editor if you want to find the perfect value easily. Just make it editable. Then you can change it in Unreal. Oh, it looks like we already have speed actually. Okay, great. We already have speed. We created it before. Okay, so we created it before a little prematurely, but that's fine. Here we already have our speed and we made it editable anywhere. And we set it to 100.0. Great, so that means we can put the speed to use in our enemy controller C++ file. Let's multiply this by speed. Okay, and I'm going to do that for the X and also for the Y. Now, one more thing I want to take into account, whenever you want to move objects, you want to take into account delta time, because otherwise your game can look very different depending on how fast the game is running, how many frames per second. So, to make sure that the game runs the same on all devices, I'm going to just multiply this by delta time, which actually comes from the tick function itself. Alright, so I'm going to do that for the X and the Y. And you want to do that whenever you're working with movement. Alright, and that is going to allow my enemy to chase my player. Let's test this out by hitting F5 or a debug button. That is going to build and compile our code, and also it's going to launch an instance of Unreal with the game, so we can test out in Unreal if our enemies are actually chasing our player. So our enemies are still going to spawn as normal, but this time they're also going to start to move. Alright, I can press play and check this out, and look at that. My player is standing still, but my enemy, oh, look at, they're moving all toward me. Alright, and as I move around, let's see if they continue to follow me. Okay, well, one of them hit me, game over. Let me start this again. I'll hit play again. Look at that, they're chasing me. Let's see what happens if I move over. Alright, they still do chase me. The previous one is still moving in the previous direction. So our game code has worked. Our enemies are chasing us. Join me coming up next. We're going to set a lifespan for our enemies, because if we never delete them, we'll never have any garbage collection. We'll just spawn enemies forever, and that can use up a lot of memory and also can be a little pointless, because then they'll just keep moving in their one direction. So join me coming up in our next lecture, where we're going to kill the enemies after a certain amount of time has passed. Hello everyone, and welcome back to our course. In the previous lecture, we tested in Unreal and wrote C++ code to enable our enemies to chase us. In this lecture, we're going to kill the enemies after a certain amount of time. Otherwise, they'll be in the game forever, using up all our memory. All right, so let's go into our enemy controller C++ file. And here, as soon as an enemy is spawned, we can set its lifespan. So this begin play, that's not only called when the game starts. It's also called when an enemy is spawned. Okay, so it all depends on what the class is. Because this is an enemy controller, and enemy controllers are spawned via the blueprint enemy, this begin play is going to launch as soon as each enemy is spawned. And each of them has their own begin play function. Here, Unreal makes easy for us to be able to set a lifespan of an object, after which time Unreal will just delete the object from the game. First, let's declare how long we want an enemy to live. So I'm going to create an integer called lifespan, and let's say we want them to live for 5 seconds. All right, we can call this lifespan in seconds because typically it's best to be clear and detailed about what your variables mean. Because someone could see a variable called lifespan and they could wonder, is that lifespan in ticks? Is it in milliseconds? Is it in minutes? You get the deal. Then we're going to call this referring to this class or whatever object this is. So this refers to each enemy. Whatever enemy is currently spawned. And then we're going to call set lifespan. And that is going to set this enemy's lifespan. And we can pass in here lifespan in seconds. Okay, so we have to pass in here how long they should live. Okay, so you can hover over set lifespan here. Get some more information about it. It comes from actor. Alright, so that is going to take each enemy, and every time they're spawned, it's going to set their lifespan to 5. And we can already test this out. We can press play with the debugger, and we can see if an enemy will die after 5 seconds. So let's press debug, which is going to compile our code and launch an instance of Unreal. Now in Unreal, I can press play and follow one of my enemies. Okay, there's one that spawned. Actually, it spawned right on top of me, so I have to restart this. I could change my range if I wanted to make sure they don't spawn on top of me. And look at that, one of them was gone. Let's see this other one. Will it disappear? Yep, it disappeared. Okay, let's look around for the next one. There's another one. Let's see how long it takes it to disappear. Okay, another one. See how long it takes this one to disappear. There we go. Okay, so they're disappearing and spawning. And feel free to change how often you want them to spawn. For example, you could have them spawn more frequently and then have their lifespan be smaller, or you could increase their lifespan as well, for example to 15 here. And then in your game mode, you can also just change this enemy timer. The smaller this enemy timer, the more frequently the enemies will spawn. Awesome, and that is how we can clean up our game by removing enemies when they've been in the game too long. Another option is just to move them around. If you don't want to be constantly deleting content from your game and then respawning it, you could also just have several enemies spawned and then randomly change their position, move them across the board or move them across the world every 15 seconds, for example, because sometimes that is better for your game speed than just deleting them. So that is another option. As always in game development, there are lots of different ways to implement functionality. It all depends on what you're prioritizing. Are you prioritizing just getting a prototype out? Are you prioritizing the game speed? Are you prioritizing memory? And so forth. Join me coming up in our next section. We're going to process collisions to be able to kill our enemy. Because currently, when our player is shooting at the enemy, the ball just bounces right off of the enemies, or the projectile or bullet. So coming up, we're going to actually be able to kill the enemy with our projectiles. I will see you in that next section.